Right, in this question, they haven't put the binary points in and they've put the numbers all stuck together. So it says we've got a floating point representation, 4-bit mantissa, 4-bit exponent. It wants you to add them together and write the answer normalized. Okay, so our first job is to work out, we're not going to convert anything to denary. Our first job is, we've got things in floating point form. If we want to add them, we've got to make sure that they've got the same exponent. Now the easiest way to do that is to just unnormalize them both. Okay, instead of like adding exponents and messing about with that, just unnormalize both and then add them up and then normalize. That's the process. So what we need to identify is what the two exponents are. So this one, the exponent is positive, because we can see the sign bit's not, is plus 3. This one, the exponent is plus 2. So that's my first job. So this first number, so I'm just going to work here on this one. So I've got 0.110. That's what it starts as. We need to move by 2 positions. So we're going to go 1, 2. That's where the binary point is when it's unnormalized. So over here, I'm going to do my calculation. So that gives me, so my first number is going to be 0.11.0. Right, I'm now going to do the second number. So I might annotate that just to show what I'm doing. So this one, I've got 0.100, but I need to move that binary point 3 places. Now, 1, 2, 3. So the binary points ended up there. I'm just going to put a 0 on. So I'm now going to put the second number on. What were we asked to do? Add them together. Yeah. So I'm going to put a plus to show that that's what I'm doing. I'm not just going to write 2 binary numbers and then put another row of binary numbers. I'm actually going to write down what I'm doing. In maths, you wouldn't just write numbers randomly on a page. You'd have to state what you were doing. Right, so this one. Now, to make sure I don't screw this up, I'm going to put the binary point first. There's a 0 on the right-hand side. Then I've got 0, 0, 1, 0. I want them to have the same number of bits. So I'm just going to extend the sign on that top one. Right, okay, so now I'm just going to add them together as if they were integers. That's all we're doing. That's the nice thing about floating point addition. It is actually just integer arithmetic. Right, so we've got 0 and 0. 1 and 0 is 1. 1 and 0 is 1. 0 and 1 is 1. 0 and 0 is 0. So that's handy. We started with 2 positive numbers. We added them together. We got a positive number. So that's good. If we have a carry, we ignore the carry, remember. Okay. Right. So that's my working out, but they wanted it normalizing. So again, to normalize this, we're looking for a repeats of the sign bit, but there is actually only one. So that's where we need to move the binary point. So we're going to move it 1, 2, 3. So the exponent is plus 3 because we went left and we'll need to make this number bigger. Right, so it was going back 4 bits for the mantissa, 4 bits for the exponent. So my exponent is 0, 1, 1. So that's my exponent. Label it. Especially as both of these are 4 bits. My mantissa is 0, and I'm going to put my point, and then it's 1, 2, 3. Only got 4 bits. Okay. So we were adding 4 and 3. And we got 7. Okay, right. The next one is a good example of how they'd never leave enough space sometimes for questions. The next one says, demonstrate subtraction in binary using 8-bit 2's complement using the equivalent of the denary calculation. So 8-bit 2's complement. So we've got to write these two numbers down in 8 bits. So we're going to do 47 minus 23. Now, before I did that, what I would do is I would say that is equivalent to 47 plus minus 23. That's what I'm going to do. I'm just letting the examiner know what I'm about to do. Right. Then I'm going to, because I'm not a hero, I'm going to write down some column headings. 8 bits, because that's what they asked for. Right, I'm going to write down what 47 is. So that's positive, and I'm going to write down here 47. Put it in brackets or something so it doesn't look like it's part of the number. Right, so no 64s. Right, so 47 is actually quite an easy number to write down. 16 and 32 are 48. So one less than that must be that. 15 plus 32, 47. Right, I don't know what minus 23 is, so I'm going to write down 23. So 23, positive number. No 32s. It's going to have a 16. Not going to have an 8 because that will make it 24. So 16 and 4 is 20 plus another 3. So that's 23. Now I'm going to do 2's complement on that to get minus 23. So I'm just going to flip until I get to that last one. There's the last one. So you could do it this way. You can do it however you want, but you could just say, right, I know that's going to be a 1. So I'm going to flip and stop there. And that's minus 23. So my addition, my subtraction or my addition that I'm going to do is going to be 0, 0, 1, 0, and then 4 ones. And again, I'm just going to write 47, so I know what it is. Then I'm going to put 1, 1, 1, 0, 1, 0, 0, 1. Got to make sure I don't transpose it wrong. And I'm going to add them together. I'm going to put a line. Got to show, if it says show you working, they want to see the carries as well. You might get marks for that. Right, and then we're going to add them up. And we got 1 and 1 is 0, carry 1. 1 and 1 is 0, carry 1. 1 and 1 is 0, carry 1. Right, 1, 1 and 1 is 1, carry 1. Oh, 0 and 1 is 1. That's a 0, carry 1. 0, carry 1. 0, carry 1. So that is our answer. They don't want it in decimal, so don't start converting it to decimal, even though we can see what the answer is, 24. Okay, but they didn't ask for that. Everyone happy with that? Again, it's process. The labelling really matters, and the worst, like I say, there were some people who didn't do that bit, but they got marks for doing this bit.